Hi, my name is Nur Ayuni binti Kamri, metric number DF210071. For the first presenter, I want to present about background this project. In background, I want to explain about the equation for this project. The equation is calculate the tensile force T in the left mesh support cable, assuming that the right support cable is wholly straight and the must join the deck in a manner that transmits horizontal or vertical force but no moment. Assume that the mesh remain vertical. Next, in the background, I want to show you about the equation we use for solving this equation. Firstly, the total, the mass. This is equation we use. Second, for calculating Fz for various z value. This is a Simpson 1/3 equation. Problem statement this project is the numerical method describes a mathematical tool developed to address numerical issue. In this very Simpson rule is implemented to calculate a vessel displacement, total weighted surface area, and the longitudinal center of buoyancy of the tool. Objectives this project have 4 points. Firstly, to explore the strategy that can be implemented to calculate complex problems. Second, to use efficient numerical integration, a task in engineering. Third, to comprehend the Simpson rule of third. What's the requirement for approximation derivative? That's all from me.
Hi, my name is Nur Shafika, number metric DF210034, and I will explain the filler table of our group. As for the facts, we examine the cross-section area of resin sailboats to proceed with the calculation with the chosen rules. Next, civil engineer should determine the effective force on the mass of resin sailboats as part of the responsibility. Besides, the idea of our project is using the numerical integration by Simpson 1/3 rule to solve the problem. We also discovered the cross-sectional area of resin sailboat may be calculated using the equation to anticipate the total force used. Other than that, the learning issue for our project are how to apply the equation to the issues at hand, how to demonstrate the effectiveness of the rules that be applied, which is Simpson 1/3 rules, and how to understand truly the function of rule that has been used. The action plans we use are retrieve the relevant information from website, article, and the numerical methods module. That's all from me. I will pass to the next presenter. Thank you.
My name is Natasha binti Abdul and I will present about the literature review. Effective force on the mass of a racing sailboat. Based on studies by Eva Gentry, the mass is sand as an unwanted yet necessary component on a sailboat that creates drags and disturbs airflow over the mainsail, reducing efficiency. The mass serves as at the foremost edge of the mainsail and plays a role in generating the propulsion force. Interaction between air, mast, jib, and mainsail trim affects airflow separation locations. Next is Simpson's 1/3 rules. Georgianema's research demonstrated the accuracy of Simpson's 1/3 rule, with the error decreasing quadratically as the number of subinterval increases. While Andrew P. Sage articles highlighted the convergence properties of Simpson's 1/3 rule, showing faster conversion compared to other numerical integrations methods for well-behaved functions. Next, I will present about the methodology. For the Simpson's 1/3 rule method, the first one is define the function to be integrated over a given interval. Second is determine the number of subintervals n. Third is calculate the width of each subinterval h by dividing the total interval length b minus a by the number of the subintervals. And then number 4 is evaluate the functions at equally spaced points within each subintervals. And number 5 is apply Simpson's 1/3 rule formula to approximate the integral. And the last one is compute the final result by plugging the function values obtained in step 4 into the Simpson's 1/3 rule formula. Next is steps calculations in Excel. First, in column A, enter the values of I, where I refers to the index representing the current subinterval. Second, in column B, enter the values of Z corresponding to the function fz. In column C, calculate the corresponding value of fz for each Z, and use the appropriate formula of function-based functions. In an empty cell, calculate the interval size h using the formula C2 minus C1 and calculate the sums of the intermediate values multiplied by the corresponding fz values and the interval size, and finally calculate the integral approximations using Simpson's 1/3 rules in another empty cell.
Hi, my name is Bingo. In this video, I'll present about the calculation and discussion for our project. So first, our project question is want to find the total force exerted in the mass. So we need to solve this integral equation. We can solve this by using the numerical method. Here is the Simpson's rule. The first step is we need to find the step size, which is the value of h here. So we can calculate it by using this formula b minus n divided by n. The n value here, I assume it to be 10. in order to get the multiple of 2 that can let us to apply the Simpson's 1/3 rule here. So we can find the A value is 0 here, B value is 30 here. So we can calculate the h, which is equal to 30 minus 0 divided by 10, which we will get a value of 3. So 3 is the step size. After that, we need to calculate by using this table, which have the initial and end value odd and even, because it is Simpson's 1/3 rules. Solve it by using Excel. So we can see at here, this is the Excel. The I value is begin with 0, then we enter it until the value of n. The 10 here is the n, which is the number of segments that the zi we just plus it with 3 because it's the step size. The step size is 3 and 0 here is the value of a. Then we drag it. At final we will get 30. It is the b value. After that we calculate the fzi, which we use the function here to find the value for the fzi, the value of this portion. So we enter it in the Excel by using this formula. So I drag it and then we arrange it in this table. So here's the initial value and the end value. And here I just copy here. So I remove the redundant one. Okay, so here is I is equal to 3 is odd. Here is all of the odd value. And here is the even value. After that, here we calculate by using the sum formula for each row. Okay, so we will get this value. So I proceed to next slide. Okay, so here is the answer that we get just now. So we apply it into the Simpson's 1/3 rules equation. The hash value that we find just now is 3. So the f0 plus fn is 23.2003, and 4 times the value of here, 2 times the value of here. Then we will get this answer, which this is the approximate value that we find from the Simpson's 1/3 rules. So that we can discuss about the value that we get. Here is the approximate solution that we get just now from the Simpson's 1/3 rules. Then we can find the exact solution here by enter this formula into the calculator. Then we will get this answer. We can find the absolute error and relative error through these two values. So the absolute error is the exact minus the approximate, and it is the absolute answer. So we will get this absolute error. And for the relative error, we divide the absolute error with the absolute value for the exact solution like this. Then we will get this answer, which is equivalent to 0.2443% of the relative error. So this error is considered small, and our approximation through the 1/3 Simpson rule is really accurate. So I think that's all from me. Thank you.
Assalamualaikum and hi, my name is Surabhi Kassim. In this part, I will explain about the conclusions. So, what we can conclude here that this study aims to illustrate how to use the numerical integration and differentiation techniques covered in Chapter 6 to solve real-world engineering issues. There are two scenarios or situations that occur most commonly. In the first case mentioned above, the function under consideration can be defined analytically, but it is too complex to be easily accessed by calculus methods. So the analytic expression is used to create a table of argument and functions value, which is then applied to this situation or cases using numerical methods. For this application, Simpson 1/3 rule calculates the total force by numerically integrating and analytical functions. That is all from our group. Thank you.